Okay, so we will continue with one component system. Okay, first thing first, you need to know what is one component system. One component meaning that it just has single components such as H2O just now. Okay, only one chemically independent species such as H2O. Okay, example we have water, H2O, or carbon dioxide system. Okay, carbon dioxide system which also have three phases in single component system. Okay, like water also have three phases. Okay, three phase such as solid, liquid, and gas. Same goes to the carbon dioxide, so it has three phases as well, but it has single component, just carbon dioxide. Okay, next is triple point and critical point. Triple point is where the equilibrium of temperature and pressure is. Okay, so normally triple point is the temperature and pressure at which the three phases, liquid, solid, and vapor, at equilibrium. Okay, so critical point is the critical temperature and critical pressure, which is normally beyond the gas. Okay, it's not possible to liquefy a gas. Alright, so look at this one. This is phase diagram. What phase diagram is? Phase diagram is drawing. Okay, we draw a diagram used to predict changes in boiling and melting by changing the temperature or pressure. Okay, it shows equilibrium pressure temperature between different phases of pure substance in a closed system. There are three main features. Normally, solid phase is stable at low temperature and high pressure. So that's why solid normally we look at very stable at low temperature. And then liquid phase normally is stable at intermediate temperature and pressure, while gas normally is stable at higher temperature. Okay, and also low pressure. Okay, this phase diagram normally it must contain temperature and also pressure under two phases such as solid liquid, solid gas, or liquid gas, which are in equilibrium. There must be two phases that are in equilibrium while the other one isn't equilibrium. That's fine. Okay, and then there is a point where three lines are joined. This point we call it as triple point. Okay, normally this point where it has solid, liquid, and gas at the equilibrium of the three phases, so we call it as triple point. Okay, so there are variation of melting point with pressure. There are two types of behavior. First, solid is more dense. Okay, or one more is liquid is more dense. Okay, this is a type of your phase diagram. Either the solid is more dense or liquid is more dense. Okay, look at this one. This is the scenario where solid is more dense. Okay, if you look at the graph of solid here is more dense compared to liquid. Okay, as I mentioned before, in phase diagram, it must have at least two phase that are equilibrium. So now this is a two phase between equilibrium between solid and liquid. Alright, and now this solid is more dense compared to liquid. Okay, so when solid is more dense, an increase in pressure convert liquid to solid and melting point will be increased. So more liquid will be converted into solid, then melting point will be increasing more. Okay, so it has solid liquid at equilibrium, yes, this part, and then the higher pressure. This is at higher pressure. Okay, when you increase more, this is at higher temperature. The solid become more stable at temperature above the normal melting point, or melting point is raised by increase of pressure. Behavior such as carbon dioxide. So carbon dioxide phase diagram is something like this. Okay. And then second one is liquid is more dense. So now you look at the graph, liquid is more dense, okay, compared to solid. So what happened now? An increase in pressure converts solid into liquids and melting point will be decreased. So more liquid will be happen here. So melting point of solid will be decreased now. Okay, so this behavior is much more applicable for water behavior. Okay, for H2O phase diagram. Okay, so now we look at phase diagram of CO2 where we say that solid is more dense, okay, compared to liquid. Right, so you look at this graph. This graph we have pressure and then we have temperature down here. Okay, so normally we have three phase, solid, liquid, and vapor, and then we have triple point. This is actually triple point. Please correct that graph. This is triple point. This is critical point, where it's beyond the temperature and pressure of the highest liquid could liquefy into gas. Okay, so this is the critical point. This is the triple point. Triple point is 3 points of the equilibrium between solid, liquid and vapor, while critical point is a point beyond the gas that can be liquefied. Okay, all right, so we have point of A. Where is A? This is at this point, A, B, C and D. Okay, so A at minus 51. Yes, at minus 51 in the triple point, which the three phases is at Z as equilibrium. And then at B, this is the point of B where critical point is. Okay, so CO2 cannot be liquefied anymore. Okay, and then C is a point of sorry, we go with AB first. AB is a point curve, boiling point curve, show variation boiling temperature with pressure. It's okay. And then along AB is a liquid CO2 and also in CO2 gas here. Okay. Then AC, where is AC? I can't show the graph back. Okay, but it's fine. AC is sublimation of deposition curve, show the variation of sublimation temperature. CO2 equilibrium between gas. Okay, triple point. Alright, it's above atmospheric pressure, 1 atm. Alright, and then AD. A is from triple point, D to down here. Okay, melting point or freezing point line. Okay, along AD is CO2 in equilibrium and liquid in equilibrium. Okay, so at this slope to the right, dia macam ni tadi kan. Okay, slope to the right, it has positive slope. So this implies that melting point increase with the pressure because of solid CO2 is more dense than liquid. Okay. Now this is a phase diagram of H2O where liquid is more dense. Okay, so now you look at graph of liquid is more dense towards the solid. Okay, where is the critical point? This is the critical point. This is the triple point. Sorry, please correct it again. This is a triple point. This is a critical point, right? And then okay, look at the slope. Alright, so this is a slope between liquid and gas. AC is between the liquid and gas. AB is between solid and liquid, and AD is between solid and gas. Okay, this is a triple point. Alright. Okay, so we stop here. We're going to continue with two component system.